Question number 10, they given two equations to us. The solution to the given system of equations is x comma y. Solution to the system of equations is x comma y. What is the value of 8 into y minus 4? You see that 8 into y minus 4, there is a term called y minus 4 in the equations as well. So here terms are matching almost, and there is no coefficient of x which is 1. If that is the case, we do substitution, but here terms are matching clearly. If terms are matching, it's better to go with elimination. So what I do is 9 into 2x plus 1 plus 27 y minus 4 equals 810. 2x plus 1 plus y minus 4, that equals to negative 393. So here what I do is I just multiply second equation with 9, first equation with 1. It's up to you, you can or not, because if you multiply with 1, you get same. I just multiplied this with 9 and then multiplied with 1 this way. So by multiplying, we can make equations of x terms similar so that we can cross out them. So this will change to nothing. It will be multiplied by 1. It will be as it is, 9 into 2x plus 1 plus 27 into y minus 4, that equals to 810. When we are multiplying second equation with 9, 9 into 2x plus 1 plus 9 into y minus 4, that equals to 9 into 393. 393 into 9. 3537 negative. So now we are going to subtract. So it's going to be, this will become 0, and then 18 into y minus 4. 3537 plus 810 will be 7, 4, 13, 4, 4347. So 4347. So we can do this with 9 2s 18, 9 for 36, 36 and 7 is there, 74, 9 8 72, 2 is there, 27, 9 3s 27. So this, the thing we ended up with 2 into y minus 4, that equals to 483. So we need y 8 into y minus 4. So y minus 4 we have to multiply by 4. So this is going to be 8 into y minus 4, that equals to 1932. So the final answer is 1932. Question number 11. A restaurant has two types of tables, rectangular ones that can each seat 4 people, circular tables that each can seat 8 people. If 144 people are enough to fill all 30 tables at the restaurant, how many rectangular tables does the restaurant have? First of all, let's write number of rectangular tables equals R, number of circular tables equals C. Actually, the number of tables are 30. So we can write that rectangular tables plus circular tables, that equals to 30 tables. And 4 people, 8 people, 144 people. We can form one equation out of this, like 4 and 8 people, that equals to 144. To balance this, how we are going to write is 4 into rectangular ones plus 8 into circular ones, that equals to 144 people altogether. So now you can see equation 1 and 2 are a bit different. So try to do elimination by multiplying equation 1 with 8 and 2 with 1. I just multiplied this C things. Why? So that I'll get the value of R. I'm just trying to eliminate C so that I'll get R. So that is the reason I'm just multiplying the coefficient of C with equation 1, coefficient of C with equation 2. So I'm going to get 8C plus 8 plus 8C, that equals to 8 3s 240, and then this will be as it is, 4 plus 8C, that equals to 144. There is no change in this. So let's subtract equation 2 from 1. So you can cross out this. You end up 4R, that equals to 10 minus 4 is 6. 13 minus 4 is 9. and then this will be 0. So r equals to 96 by 4, 4 times 1, 4 times 2 times 4, r equals to 24. So option D is correct. Question number 12. The given two equations to us. In the given system of equations, and n are the constants. The system has infinitely many solutions. What is the value of by n? This said system has infinitely many solutions, which means for infinitely many solutions, the equations must be similar. So how can we make equations similar now? Here we can't take, because you can see in the place of its coefficient is 2 here and it is 6 here, it is n, so it's different. So how can we make sure that these two equations are similar? Check the constants if that is the situation. So how can we make constant similar? We can multiply this second equation by 2 so that the constant of second also turns to 10. So now what happens? First equation will be as it is similar, mx minus 6y that equals 10, and second equation is going to be 2x minus ny that equals, we need to multiply 4x minus that equals to 10. Now coefficient constants are same. Now these two equations are exactly same because they are in the condition of infinitely many solutions. Now we can get the value of, just equate the coefficients of x. So you get equals to 4. Equating this, 2n equals to 6, n equals to 3. So we have the value of m and n, but we need to find the value of by n. So m by n equals to 4 by 3. So that is option C. One of the equations in a system of linear equations is x minus 2y equals to 5. The system has exactly one solution. That is the condition. Which equation could be the other equation in the system? So the first equation is x minus 2y equals to 5. Out of this 4, which one among them will be the equation of second which results exactly one solution? That is the given condition. So how can we figure out this? So I'll just take equation 1. I'll just take this option A, which is negative x plus 2y that equals to 0. The condition is one solution. So what do we know? First of all, infinitely many solution. Equations completely same. No solution except constants. Equation same except constants. What about one solution? For one solution, constant and x and y terms also different. Complete equations must be different. What does that mean? Like, not complete in the sense x and y terms both won't be same. Constant must be different. At the same time, this, even if it is variable of, terms of x are same and terms of y are different, then it is then it comes under one solution equation. If y terms are same and then x terms are different and constant is different, then also it comes under one solution. If x terms are different, y terms are different, constant also different in the given two equation, then also it's one solution equation. Let's see. First I took option A. Now let's see, can we able to do some manipulation and check whether it matches with any among the equations. So if we multiply this second equation with negative 1, we multiply this second equation with negative 1, what happens? The first equation will be x minus 2y equals to 5, and the second equation changes to x, and then it's going to be negative 2y, and then this will be 0. If you see the left side, x terms and y terms are same and constants are different. If that is the case, this comes under no solution, which means option A is incorrect. Now let's go for option B. So first, the equation we have is x minus 2y that equals to 5, and the equation from option B, x minus 2y that equals to 0. So here clearly, after watching these two equations, x terms, y terms are all exactly same and constant terms are different, which means this is also not correct, because if that is the case, we say these two equations are under no solution condition. Now let's go for option C, which is x minus 2y that equals 5, and then option C is minus x plus 2y that equals negative 5. This is the given C equation. So if you see, by manipulating this equation, by multiplying by 1, we are going to get equations almost same. Let's see, x minus 2y equals 5, and then we are going to get positive x, negative 2y, positive 5. You can see x terms, y terms and constant exactly same. This comes under infinitely many solutions. So option C also incorrect. We need one solution equation. So let's go for that. Option D is left. So option D will be the answer. X plus 2. One second. The given first equation is x minus 2y equals 5. And then second equation is x plus 2y equals negative 5. You can see constant terms are different and y terms are different, x terms are same. So constant terms are different and y terms are also different. So we can consider that this equation as no solution equation. Even if you want to do any manipulation, it will still be into a same equations. What does that mean? Like y terms is going to be same. You can't, even if you multiply this with negative 1, you're going to get negative x and then negative 2y and then positive 5. So here, if you do that, constants are same, but your x terms will be different. If even if you manipulate, x terms are still different. So it is not coming under infinitely many solutions. Let me write it. Even you manipulate, you are going to get x minus 2y equals 5, and the second equation you're gonna get negative x, negative 2y, that equals to positive 5. Even you try to manipulate, you see you're not going to obey infinitely many solutions. For infinitely many solution, exactly equation must be same. So this is also this not working. And no solution, constant must be different for no solution. Rest x terms, y terms must be same. Here x terms are different, y terms are same, constants are same. So it is not coming under no solution. Next, one solution. Here in one solution, constant must be different, x terms must be different, y terms also different. It's like it does not obey these two, and sometimes x terms will be same, fine. Y terms will be same, fine. X terms will be different. Then in that situation, we say it's a infinitely many solution. Actually, manipulation not required, because here after watching this equation 1 and 2, we understand that x terms are same but y are not same. Even if you do manipulation, they will be one term will be differ, that is x. So definitely option D will be the right option. It's not obeying both of them, so obviously it will be one solution equation. So not A, not B, not C, it's D. Question number 14. The given two equations, if x comma y satisfies the given system of equations, what is the possible value of y? So the given x square minus y square equals to 1 by 12, and the other equation x minus 2y equals 0. We have to find the possible value of y. What is the best way? Is it substitution or elimination? Whenever this coefficient of x is 1 or something like that, it's better to turn that, like use that and do substitution, because it's easy now. You have the value of x, just substitute that value of x in the first equation, you'll get the value easily. So 2y whole square minus y square, that equals to 1 by 12. So this is gonna change to 4y square minus 3y square equals to 1 by 12. Sorry, it's y square, not 3y square. It's going to be 3y square now equals 1 by 12. Y square equals to 1 by 36. Y equals to plus or minus 1 by 6. Here they given negative 1 by 6. So that will be the possible value of y.